Hi, in this lesson we are going to look at Java literals. Previously we have created some variables and we have assigned them different values. So for example, we have created a variable called age of type int and we have assigned a value 24. So here we are writing 24, right? So this is called a literal because it has a constant value. 24 is 24. For example, for age I can assign 25 and the value of age is changing to 25, but here 24 is always 24. This is a literal constant. Here 25 stands for 25, right? But if you see these two statements, at the end of this statement age variable is holding 24 and here age is holding 25. So the value of age can change, but the value of 24 is always 24. So these kind of values that we write are called literals. 24 is a literal, 25 is also a literal. In Java, numerics are by default of int type, so we can call this int literal. Okay, this is of type integer. Okay, so if we have to assign some value to long, we can obviously assign a integer because long is having 8 bytes whereas integer size is only 4 bytes. So whatever can fit in integer can fit in long also. So we can simply assign 2 million or 2 billion, this I don't know. Yeah, it looks 2 billion, right? Yeah, it's 2 billion. We can assign 2 billion to population, but if we want to assign 20 billion, okay, so this is more than integer value, so it cannot be an integer literal. So if you see here, integer number too large, because integer can hold around 2 billion value. We will see that later, but this 20 billion is too large to be a integer, so it cannot be a integer literal. Okay, so if to represent a long literal, we have to append L at the end. So now this is considered as long literal. Okay, so these are the only two integer literals that we have, integer literals and long literals. Okay, these literals can be represented in decimal system. For example, here I am writing 100 in decimal system and it is a decimal literal. The same 100 value can be represented in hexadecimal also. Hexadecimal 64, actually it is not 64. Hexadecimal 64 is equivalent to 100. As we know, decimal system, it can have numbers from 0 to 9, whereas hexadecimal can have 0 to f. So that is the reason this is going to be a bigger value, more than even though it looks like 64, it is not 64. Okay, we don't call it 64 also, hexadecimal 64. So the decimal equivalent is 100. This 100 can also be represented in boolean. So whenever you are representing in boolean, we have to prefix with 0b. Okay, previously when we are representing in hexadecimal, we are prefixing with 0x. This x can be capital or small. Similarly, this b can be small letter or capital letter, that is fine. Okay, so there is one more system called octal system. So here the numbers vary from 0 to 7, so it cannot have 8. Okay, so if I write 8 here, it is going to be an error because the literals that are starting with 0, they are octal numbers. So octal numbers don't have 7 in them. Okay, so it should be 7. Oh, sorry, it should be sorry, what was that previously? 4. Okay, so it can have up from 0 to 7 because it is a octal number and octal numbers start with 0. This is very confusing, right? I mean 0 1 144 we generally treat as 144. We don't immediately think that it is a octal number unless we are having so much exposure to octal numbers. So generally this kind of octal literal representations are discouraged. So we are not going to use that in our course at all. We will use decimal literals. Sometimes when required we will use hexa, but binary also very less. We are not going to use them unless we need to. So here we have seen how to represent decimal value 100 in 4 different systems: decimal, hexadecimal, binary and octal. So when we print these values, obviously all of them are going to print 100. Okay, good. So next we are going to look at long. Here we have looked at long already. So if we are writing this kind of large number, now it is very difficult. I mean it takes some time whether to know it is 300 billion, 32 billion or 3 million, whatever. It is going to take time to actually know the value. Generally when we write, we either keep comma or dot in between numbers, right? When we are writing in accounting systems or anywhere the billing systems, wherever we see, we generally see this one. So go from Java 7 onwards, comma is not a valid thing because generally values are separated by comma. So we can't use comma to separate integer numbers. So from Java 7 onwards, we can separate these literal values by underscore. Here if you see, the same value is represented in binary. It is so long, even it takes time to count how many zeros and ones are there, right? So it is very helpful to have some separator. But what happens is compiler is going to ignore these underscores. These are there for our benefit. I can simply read it that 320 million, right? Because there are 6 zeros now. Okay, so not only these kind of long numbers, even these small numbers like 100, right? It can be separated by underscore. Underscore can be inserted between any two numbers. Okay, so here if you see, I inserted underscore here, it did not complain. But underscore cannot come at the beginning. This is an error. It cannot come at the end. It is an error. It cannot come where, I mean, after B or those things, because as I said, the underscore can be included only between the numbers, between two numbers. Okay, yeah, that is it about underscores. So what have we learned so far? By default, whatever integer numbers we are writing, they are of type integer. So if you write 25, it is an integer. If you write 2 billion, it is an integer. You cannot write 20 billion. So for example, this is fine, 2 billion, but the moment I try to write 20 billion, it is not going to allow. As I said, unless you append L at the end, it is of type int, and 20 billion is not a valid integer value. We will see that why 20 billion is not a integer value, because it cannot be held in 4-byte memory. Okay, so the moment you write L here, then you have to assign it to a long variable. It is going to become long literal, and these literals can be represented in one of these 4 systems, and for the readability purpose we can include underscore. That is what we have learned so far. Okay, from integer values we can now move to floating point values. Okay, so floating point values can be represented like this, or they can be represented using scientific notation also. Similar to our literals, integer literals, floating point literals are also of 2 types. If you don't include f here, for example, if you see here, there is no f appended at the end, so these literals are considered double literals. There is a floating point, so this is a floating value. In Java, fractionals are represented by only float and double, so this is a double value. Okay, if you want to treat it as a float, you have to append f here, otherwise it will be considered as double. Okay, so here for float interest rate 1, I am assigning 3.2 float value, but if I omit f here, as I said, this 3.2 fraction value is going to be a double. Okay, previously we have seen that float has 4 bytes and this double has 8 bytes, so double value cannot be stored in a float. Okay, so for that reason it is giving an error. Okay, double to float, it cannot implicitly convert from double to float. So we have to give f here whenever we are assigning to float values and we want to treat a literal as a float. Okay, that is about floats. Okay, if you see here, note, by default fractional numbers we use are double literals. These are the fractional numbers. Okay, but if you want a float literal, then we need to append it with f. Okay, and as we have already seen, boolean literals are only two values, true and false, and it is easy to represent those two values, two literals, two boolean literals. Okay, then moving on to char. Okay, as we have seen, character will have one character, can save one character, and it takes 2 bytes. Then this is how we represent character A. In Java, single quotes and double quotes are not interchangeable. For example, if I write double quotes instead of single quotes, it is going to give an error. Okay, whenever you include something in double quotes, that is treated as string, not character. Okay, so character A has to be represented in single quotes. These numbers have a numeric value. As I have said, character is going to take 2 bytes, and even we can save integers in that. The A has a value of 65. So when I assign integer 65, it is going to treat it as A, or A is treated as 65. They are interchangeable basically. Okay, this is a 41 is hexadecimal representation of 65. So we can even assign character values using their Unicode. Actually, Unicode is written in a hexadecimal system. So as we have seen, it is going to take 2 bytes. 2 bytes can represent from 0000 to FFFF. We will see that again when we revisit primitive types. For now, just remember that we can assign Unicode values. Unicode's values will start something like this, \u, then whatever is its value. It will be always 4 numbers ranging from 0 to f. Okay, so the minimum value is 0000 and maximum value is FFFF. Okay, what did we write previously? 0041, which is hexadecimal representation of 65. So when I print these 3 characters in this statement, they all should print A. Okay, you should not see A, 65 and 0041. You should see all A's. Okay, now moving on. For example, we want to represent a character which is single quote. Because we are including characters in single quotes, we cannot simply write, okay, here I can write A, right? A is a character, but single quote is also a character, but I cannot directly write it, right? So it is going to give an error. 3 single quotes is not a valid syntax. So I have to escape it with a \. Okay, now it is going to allow single quote. For example, if I print this one after this, okay, or between these two, it is going to print a single quote. Okay, that is good. So here we are seeing that to escape something we are using \, right? So whenever you write \, you are escaping something. For example, you want to print \/ itself. So in that case, you have to escape it with one more \. So I'm going to print this one also here. So when character 7 is printed, it should print only single \. As \/ is a sequence, escape sequence, we have to write one more \/ to escape this \. That is a tricky thing, right? Yeah, okay. There are some characters like new line and tab. They are going to take only one char value. They can be saved in one character. But if you see here, they look like 2 characters, but they are not 2 characters. They represent only one character. We have some more escape sequences like this. When we come across, we will see them. But please remember, there are escape sequences also. We are escaping some values like single quote and \/ with a escape character, and there are also some escape sequences are there. Okay, that is all about character literals. These are all literals only because we are writing them as a literal. Okay, these are not variables. This is a variable, this is a data type, but the value we are assigning is literal of type char. Okay, yeah, let's run this program. Let's see what is going to be the output. What are we printing here? Here we are printing score 1 to score 4, and as I said, these are all nothing but values of 100 in different systems. Okay, then here we are printing American population. So population of America, it is 320 million. Even though we have included so many underscores here or here, they are not going to be printed, they are going to be simply ignored. So that's okay, they are for our readability purpose. Then what else we are going to get? Okay, here we are going to char 1 a, char 7 is backslash, char 2 is a, again char 4 is single quote, and char 3 is again a. Okay, so why did I include double quote here, right? Let's see what it prints with double quote and what it prints without double quote. Let's run this program. So as I said, all score 1 to score 4 are going to be 100. Then American population 320 million. Then we are seeing 3 A's and backslash and single quote. That's good. If I don't include double quote here, let's run without that. Wow, I am seeing a value 326. What is happening here? Because plus is trying to sum up values. Okay, plus is additional operation, right? 2 plus 3, 5. So here it is trying to add the numbers that these characters represent. For example, as I said, a is represented by 65 internally. 65 is a number that is used to represent a. So this is 65, this is 65, and this is 65. I don't know the values of these two, but these 5 together, they are making a sum of 326. So if we concatenate it with a blank string, so as here I have said, right, strings will be included in double quotes. So the moment I start concatenating something with a string, these all will be treated as characters. Okay, and everything can be represented as a string. Okay, so a can be represented as a string a. Also this backslash can be represented as string with a content of backslash. So the moment I write this, everything will be treated as string and they will be printed. That is the reason we are seeing a backslash a single quote a. Okay, that is all about literals. It is easy to understand literals. Basically, whenever we are assigning some values like 25, 2 million, or character a, or some floating value, these are all literals. The main thing we need to understand is, if we just write a fractional number, it is going to be a decimal literal. If we just write a whole number, it is going to be an integer literal. And some number like 20 million, or not 20 million, 20 billion cannot be represented in int. So you just cannot write 20 billion, because that is not a valid integer. So not a valid integer literal also. So we can't do that. Okay, so go through these different statements, try to understand this 4 systems: decimal, hexadecimal, binary, and octal. Then make small changes to this one and execute again to see it for yourself. Okay, thank you for watching. Happy learning. Thank you.